Welcome to Chapter 12 of my IPv6 Fundamentals book review. Here we're doing again Chapter 12, EIGRP for IPv6. Again, all of this material is owned by Rick Graziani. He's prepared the PowerPoint slides, he's written the book, all of this is for him. Here's the IPv6 Fundamental book and the live lessons. Again, all written by and owned by and copyrighted by Rick Graziani. There are the appropriate ISBN numbers for all the material. Alright, so let's jump right into it. EIGRP, IPv6. So when we're looking at the different types of routing protocols, distance vector and link state, we have like a RIP v2 for IPv4. The third version became the next generation, or NG. When we're talking about EIGRP for IPv6, it's EIGRP for IPv6. For OSPF, it's v3 and so forth. Again, this is going to be the next evolution of these routing protocols using the appropriate IPv6 standards. And then again, BGP, there's going to be the BGP for IPv6, also known as MPBGP. So again, the specific routing protocols, we're focusing just on EIGRP. The basic operation and algorithms for IPv4 apply to IPv6. For example, the advertised routes, networks versus prefixes, distance vector, yes, converge, still uses the dual. The metric still uses bandwidth delay, as well as the reliability and load. They both use the Rail Transport Protocol, basically an advanced version of TCP. Both do partial and mounted updates. They'll do hello packets for their respective IP versions. Source addresses, again, they're going to be doing that. They're also going to be using multicasts. Here we're going to be using the prefix FF02 for multicast, ::A, which happens to correspond to 10. Here we have the multicast 224, 0010. So you'll notice 10 and A are still similar. MD5 for authentication, and they're both using a 32-bit router ID. So comparing the two, with IPv4, you have a neighbor table in both routers, and a topology table, and a routing table. With IPv6, you have the same thing, except they're separate tables. So each router will have its own separate IPv4 and IPv6 table. Again, it's going to use the source IPv6 address, which should be its link local address, and then it will use the appropriate multicast address, or if it's only sending to a direct neighbor, it will use the IPv6 link local address. Again, that FF02 : A is similar to the IPv4 version of a multicast 224.00.10. Because again, when you look at A in hexadecimal, if you convert that to binary, or well, not binary, decimal, you get the number 10. So again, link local, multicast. So let's look at the classic EIGRP for IPv6. If we're going to be doing a SHIP interface brief, you'll be able to see serial links are used in this topology so that we can differentiate between the LANs and WANs. If we do an IPv6 brief, you're going to see the serial interfaces, both their link local and their global unicast address. Same local addresses you'll see on two serials, but again, that link local is only on that link. So even if you have a router with multiple links, each link may have the same type addresses for the FE80s because they're link local addresses. So let's go ahead and look at this for EIGRP for IPv4. you do router EIGRP, the appropriate AS number, the ID, and the network statements. Here, if we want to have a default route to our ISP, we'd do a static route, and then we would redistribute that static route to everyone else with the redistribute static. If we do a show IP route, you'll be able to see the appropriate external EX addresses learned through EIGRP, and then the summarized addresses. So let's talk about IPv6. Very similar to IPv4, you have to make sure you have IPv6 unicast routing turned on. Then you do IPv6 router EIGRP 2. Here the number 2 is going to be the AS number. EIGRP AS must match the other router because, again, this is going to be an internal autonomous system number used for this network. You set the router ID. Same process for a 32-bit router ID in IPv4. You turn it on. That's it. You're going to have to configure EIGRP on a per interface instance. So basically you do IPv6 EIGRP with the appropriate AS number for all interfaces. And if you're doing this in Packet Tracer, one thing that I have noticed is I'm doing videos for my scaling networks and eventually my WAN class. When we're doing ranges of addresses with IPv6, they don't always work well. Again, the appropriate AS numbers have to match throughout the network. Here we're going to look at R2. Same general items. Again, you may want to make sure that you do the no-shut when you're doing EIGRP, just to make sure that it's on, because some older routing protocols, some old ISOs do not like the current routing protocol. I apologize for that. So yeah, you want to make sure that EIGRP router, EIGRP, the appropriate AS number, is actually turned on for the no-shut. And again, router 3, here, we're also going to do a static route to our ISP. And then again, the appropriate EIGRP ID, we're going to be distributing the route here under the router EIGRP command. And then we will configure each of the appropriate interfaces to be part of that EIGRP group. The static, or the redistribute static, will allow us to redistribute that static address to all the other routers. Let's go and look at our neighbor tables. If you do a show IPv6 EIGRP neighbors, similar to the OSPF neighbor tables, you can see the appropriate addresses, interfaces, hold timer, and that's going to be more like the dead timer. You'll see again, it's using the link local address. Because the link local address is being used, the egress interface, or the interface that with the update was learned, must also be included. So you'll see the next item is that interface. So if we're doing a topology table, you can see, again, all of the appropriate routes, and typically the appropriate feasible successors. And some, you should see the successors, and occasionally you'll see a feasible successor. FD, feasible, not feasible, feasible distance. And then we have our successors. Here we are not showing any of the appropriate feasible successors, but if there's multiple pathways, you can see them with the EIGRP topology. Link local addresses, again, feasible distance, and that's how we come up with the appropriate successor. and the appropriate feasible successors based off that distance. Let's go look at a route table. It's only going to show the successor, even if it has multiple paths to from A to B, for example. It's only going to show you the primary, the first success. It will not show you any of the backup routes, even if it has backup routes. Again, notice the appropriate link local address being used as a next hop address, the administrative distance, and the appropriate metric, the default route, which is distributed by R3, hence the external link. You can also do the summarization. You can do it statically or manually. And if you manually do it, you can do it like that. Underneath an appropriate interface, you can do a summary address, EIGRP, and then the appropriate summarized address. /62, why? Because when you do the math and the summarized addresses, the summary address should be /62. You could also do a IPv6 route, EIGRP, and then again you're going to see the appropriate summary's address being sent to the other neighbors. I'm going to grab my pen. There we go. Oh, got ahead of myself. If you want to verify the addresses with a show IPv6 protocol, you can see the summarized addresses. You can also see if it's being redistributed. So let's go look at EIGRP for IPv4 and IPv6. So with that, you'd have the appropriate network statements. If we're doing IPv6 as well, there you go. You turn on IPv6 unicast routing. You'd set up the appropriate routing protocol on the router, and then you enable the appropriate routing AS underneath the appropriate interface. This basically allows us to use IPv6. You can configure IPv6 without having that turned on, but nothing will happen. This right here basically is setting addresses. This is assigning the IPv6 portion of this interface to use EIGRP2. This is setting up EIGRP2. Let's go ahead and get into the named portion of the EIGRP for configuration. It's a little bit more advanced. So classic EIGRP does require you to do separate EIGRP configuration modes and commands. Named EIGRP configuration is a more recent method and allows us to do both for IPv4 and IPv6. So a single mode to gather all EIGRP commands in one place. We'll use address families, unify EIGRP, IPv4, and IPv6. And part of this deals with that VRFs, and that's a virtual routing and forwarding. Alright, so let's go and let's look at how we do that. Enable IPv6 would be setting up router EIGRP and a name. Here we're having a virtual instance name. This does not have to match other routers, but normally it does. We're going to do an address family. If you do address family question mark, you can see that we're doing, or we could do both IPv4 or IPv6. So here we're going to do a address family for IPv4. It's going to be a unicast. We're setting the appropriate AS number to 1. We're going to be setting it the router ID, the appropriate network statements. We can exit the address family. Alright, so you're going to notice here, once we go to address family, That became our subcommand. Once we exit the family, we're still under the router portion. We're just not under the router address family portion. That allows us to now set up the address family for IPv6 using a secondary autonomous system number. Notice both IPv4 and IPv6 underneath the router EIGRP dual stack. Again, you're going to have, they don't have to match, but these are going to have to match on the other routers, because these are, again, the autonomous system numbers for EIGRP that will have to be used in other areas. By default, all IPv6 interfaces are enabled for EIGRP version 6. And then again, you set the router ID because you're going to be setting these underneath each address family. Same thing for router 2. Again, you're going to have to make sure that the AS number is appropriate and the same as the other routers. Router 3, same thing. Again, pay attention to these guys right here. They have to match throughout. We have to have a default route. So let's go back to router 3. We can set our default routes both for IPv4 and IPv6. And again, go back into those address families. And we can do a topology base. That topology base has some things to it. So if we do a topology base, it takes us to a sub-interface address family topology. We're looking at things like auto summary, redistribute, variance. Well, here redistribute and auto summary are the big two. Redistribute, maybe the big one. That's going to be for IPv4. So again, here we have our static routes. Here we set up the appropriate items. Topology base allows us to redistribute the static route. This is for IPv4. We're going to exit the address family topology, exit the address family, then move on to the appropriate address family for IPv6. We're going to be going to its topology base, and again, we're going to redistribute the static route into this autonomous system number. Because these are going back to those autonomous system numbers. If you want to verify, you can do a show IP route or a show IPv6 route, and you should be able to find the appropriate default routes. You'll notice here 192.168.770/24 is not advertised by EIGRP because we did not include that as a network statement. Again, here's how you do the appropriate IPv6 version of it. Again, the default route and the appropriate links. Here, this guy is this network. Because with IPv6, all interfaces are included when you do the named EIGRP. Again, all IPv6 interfaces are enabled automatically. How do I remove the appropriate prefix or an incorrect prefix? Named, go back to address family, make sure that we have the appropriate address family and the appropriate AS number, and then you can actually go to the interfaces, turn off the interface, go back out, do the show command so you can see the details of the interface, verify. But you'll notice when you do that, you see that being up. We disabled it here, but this was underneath IPv6, not under IPv4. So this is still going to be up for IPv4, but not for processing IPv6 commands. Again, you can always do the appropriate show commands to see all the routes. You're no longer advertised by EIGRP because we've disabled it, and we turned it off for IPv6. So address families, interface options. We can do hello timers and intervals. We can make them passive, summarize them, shut them down, authenticate. Again, same thing that we've been doing with IPv4. Again, disable, passive. So let's look at how we make them passive. So again, we're going to go to our dual stack, go to our address family, go to the appropriate interface, make them passive. That will suppress EIGRP messages, leaving that interface. Again, we'll have to do this inside each of the address families. And that's how you do it. Again, because this is going to be the passive interface for this instance, using that appropriate AS number. If normally we want to make things like our LANs passive. So this guy and this guy over here, those should be passive. So again, on router 1, the address family, IPv4, the appropriate autonomous system number, the appropriate interface for our LAN, passive interface, also for IPv6. We have to make sure that we're turning off both. If we turn off just one and we leave the other, it will suppress the one that we turned off. But the one that's still on will still send EIGRP messages out for that IP version. So for example, let's say we turned off IPv4, so we made that a passive interface. We won't be sending EIGRP updates for IPv4 at that interface, but we'll still be sending IPv version 6 out of it because we didn't set the IPv6 passive interface. I know in this example we did it for both IPv4 and IPv6, but if we didn't do both, then whichever one we did not do, that one will still be not broadcast, but that one will still be sending messages out to that interface. Manual summarization. Again, address families, the appropriate interface. You can always summarize addresses for them to be redistributed, just like we've done before. So let's go ahead and we can verify them by doing show IPv route. There you go. You can be doing the same thing with IPv6 with a show IPv6 route EIGRP, and again, there you go. How do we verify things are like writing protocols are functioning correctly? You can do a show IP protocol. You can see the things like the statics, the router ID. Oh, I'm going to go back one. The appropriate K values and bandwidth values, hold timers. You can see the summarization, if it was automatic or manual, for the appropriate networks that it has, and what passive interfaces it has. We can do the same thing with IPv6. There is our router ID, and again, the interfaces, redistribution, summarized addresses. So let's go ahead and let's look at our router 3's configuration. Address families, the appropriate network statements, the appropriate router ID, the appropriate passive interface. Here we're doing again summarized addresses for serial, but we're also doing a redistribute static. All of that's going to be under the address family for IPv4. Next will be the address family for IPv6. Again, the appropriate address family interfaces, the appropriate topology base for distribute static. Alright, so let's go and look at EIGRP configuration at a glance for renewal. Again, here we have IPv6 and IPv4 for both EIGRP, and we now have the named version. We can do either or we can do named. That's the end of this chapter. We have one chapter left, and we're going to talk about OSPF. Again, all material was taken from the IPv6 Fundamentals book. You can also access his lessons. All of the credit goes to Rick Graziani. If you have any questions, please let me know. Thank you.